All right, we're going to look at types of polar graphs. And when we start this lesson, it's going to be challenging, but at the end, I'm going to start to give you shortcuts. And we are only going to cover one type today, okay? So there will be a part 2 to this video where we look at the other type, okay? We have 3 types of symmetry tests. We have the x-axis, the y-axis, and the origin, symmetry with the origin. I gave you the problem r sine 3 theta. Okay? R sine, 4 sine 3 theta. Okay? So, we're going to do, if you look at the test, you have to do opposite of the radius, opposite of theta. We are simply going to do it algebraically right now. So negative r equals 4 sine 3 negative theta. Okay? So the negative can be in front of theta or it can be in front of the 3. So negative r equals 4 sine negative 3 theta. Okay? It can be in front of theta or it can be in front of the trig. So negative r equals negative 4 sine 3 theta. So all I've simply done is taken this negative and I'm going to keep bumping it up. Okay? So now I'm at negative r equals negative 4 sine 3 theta. What would you like me to do? Divide by what? Negative 1. What I do to one side, I do the other. So my answer is r equals 4 sine 3 theta. What do you notice? I get the same exact. Okay? You're testing. If I can flip r and theta and get the same, then it is symmetrical with the y-axis. Okay? Question. So flip r? Yes. So if r was negative 4, now it would become positive 4. Okay? So, okay? But we just did it algebraically for right now. Okay? I'm going to give you another problem that you are going to do algebraically. Okay? So, this time, I want you to check for x-axis symmetry. Okay? And it's going to be r equals 5 cosine, let's go with 2 theta. Okay? And I'm just asking you to check x-axis symmetry. And do it algebraically for right now, and I'm going to explain in a minute. Okay, so in this one, I'm going to keep r, I'm going to flip theta. So that would look like this. R equals 5 cosine 2 times a negative theta. We're going to just keep bumping it up again. So r equals 5 cosine negative 2 theta. R equals negative 5 cosine 2 theta. Okay, so when I did it algebraically, it didn't work out, right? This is not the same as the original. Okay. Now what we're going to do is we're actually going to test it by plugging in a number, okay? So give me a number for theta. Theta. Guys, theta is what? Angle. We only worked in a special type of angles. You like 30? Okay. We're going to go with 30. So we need theta equal to 30 and theta equal to negative 30. Okay? So listen up for a second. Okay? When I do 30 degrees, if I do the cosine of 30 degrees, so hand trick, what do you get? Square root of 3 over 2. Positive or negative? Why? It's in first quadrant. Excellent. So negative 30 is how many degrees? 330 degrees. 330 degrees is what type of angle? Hand trick, what type of angle? 330. It's a 30, a 45, or a 60. What is it? It's a 30. So it's going to be square root of 3 over 2. What quadrant is this? Fourth, okay? All students take cash. Cosine is positive. Wait a second. 30 and negative 30 give me the same thing. Okay? So cosine will have x-axis symmetry. Okay? So I had you do it algebraically, but technically the best way to do it is to plug in, and it doesn't matter if it's a sine, cosine, tangent equation, it doesn't matter. You plug in an angle, and then you plug in the opposite of that angle. Okay? Right, so if I plug in that angle and do the math, and I plug in the opposite of that angle and do the math, and I come out with the same answer, they are symmetrical. Right, because algebraically through us, yep. Doesn't matter. Okay? Good? Yes. You should really plug in an angle, okay? Yes, ma'am? It still works to plug in the number. Right, when you plug it in, so think about this. I'm going to replace theta with the square root of 3 over 2. I'm going to replace theta with the square root of 3. If I replace it with the same number, right? So 2 times the square root of 3 over 2 is the square root of 3. 2 times the square root of 3, it gives you the same exact. Okay, so for x-axis and cosine, okay? If we did some other types of equations, you would see the difference. Okay. Okay, so really, you should plug in a number for theta. That's a good idea. Now, somebody asked here, why could I keep bumping it? It doesn't matter if I double the angle and then flip the sign, or if I flip the sign and then double the angle, you get the same, right? 2 times 30 is 60, all right? And the opposite of that is negative 60. The opposite of 30 is negative 30. Double that is a negative 60. We get the same answer. Yes? That's why you could keep bumping the sign through. Good? All right, moving on. So flip your paper over. We are going to tie in what we learned last week to some special polar graphs. Okay, some special. All right, to start this one off, this is the equation. R equals 3 plus 3 cosine theta. I am going to start with quadrant 1. What are the values of quadrant 1? 0, 30, 45, 60, 90. Quadrant 1 is the only one that has 5 numbers. The other 3 quadrants only have 4 values. Okay? Now what I'm going to do is I'm simply going to replace theta with the value. So 3 plus 3 times the cosine of 0. What is the cosine of 0 degrees? It is 1. 3 times 1 is 3, plus 3 is 6. How would I plot this ordered pair? What pole am I on? 0 pole and a radius of 6. Unfortunately, I didn't give you enough rings, so we're going to add the 6th ring. I only gave you 5 rings. Sorry about that. Okay? Good so far. Okay. Now I'm going to do 3 plus 3 times the cosine of 30. The cosine of 30 is square root of 3 over 3. So this ends up being 3 plus 3 the square root over 3. Sorry, 3 over 2. Which ends up being about 5.6 because this is about 2.6. And that's going to be important in a minute, okay? All right. The square root, 3 times the square root of 3 divided by 2. Okay. 45, help me. Oh, sorry. So let's plot this. So technically, if I get enough points the other way, and I did this in the other classes, we could skip 30 and 45, but we're going to need them later. So I'm going to plot 30 degrees is 5.6. So 5.6 is like there. Okay? Okay. Are we good? We'll call it 2.5, so that's 5.5, make life easier. Okay, so then this is going to be 3 plus 3 times the square root of 2 over 2. Why did I have the square root of 2 over 2? That's what cosine of 45 is. Now, this is approximately 2. It's 2.1. We're going to go with 2, right? Okay? So 3 plus 2 is 5. So on the 45, I'm going to put a dot at 5. Okay? Good so far? All right, now it's going to get easier. 3 plus 3 times what? 1/2, which is 4.5. Well, it is 1.5, and when I add the 3, I get 4.5. So 4.5, which is there. Okay? 90. What is the cosine of 90? 0. And 3 plus 0 is 3. Boom. There we go. Good? And we can go ahead and connect these first couple dots. Okay. I connected the first 5 dots. You know, when you were a kid, connect the dots, first, second, point 1, 2. Yes, you with me? Okay. Now, let's see. Don't fail me now. What are the 4 angles in quadrant 2? 120, 135, 150, 180. Okay, why did I do this in blue? It's the reference angle, and it saves me work because I can look at the reference up here. Yes? Okay, so 60 degrees, what am I supposed to do? Wait. Is what? So am I going to add 1.5 or subtract it? I'm going to subtract 1.5. So it's 1.5. Okay, so look at it, right? This here is worth 1.5. But because it's in quadrant 2, I'm going to do negative 1.5. So 3 plus 1.5, sorry, 3 minus 1.5 is 1.5. So that goes here. Okay? Good? Okay, so whatever's here Whatever second, I do the opposite. Am I going to do the opposite of 3? No. Okay. 45 is 3 plus 2. So I'm going to do 3 minus 2, which is 1. So this goes here. Made a goof earlier today because I let them just switch them, and you can't because the 3 is not connected to theta. All right, so 30. Looking at the 30. 3 minus 2.6 is 0.4. So that goes right there. Okay? Good? All right. Now, what is the third quadrant's numbers? 210, 225, 240, 270. Keep me honest because I messed up 270 twice today. All right, so this is a 30. This is a 45. This is a 60. This is a 90. All right. So, in quadrants 3, cosine is still negative. So my answers are going to be the same as the answers for quadrant 2. So the 60 is 1.5. The 45 is 1. The 30 is 0.4. And the 90 is, no, I have to get the 90 from over here. The 90 is going to be 3. Okay, so that gives me a dot here, a dot here, a dot here. Oh, I skipped a dot, sorry. I skipped a dot. All right, so the dot should have been here, then here, then here. Okay, now raise your hand if you feel like I need to finish this or if you can finish it without doing the coordinates. Yeah. So what's this one going to be? This one here. So it's going to line up with this. So it's going to be here. This one's going to line up here. This one's going to line up here. And there it is. Good job. Okay? This is the hardest type to do. This is a type of Le Méchant. We will learn the shortcuts for Le Méchant tomorrow. Okay? All right, moving on. Okay. Letter C, R equals 5 sine 2 theta. Now, I learned my lesson on this one. This is the one where I think I missed 270. Okay, so we have 0, 30, 45, 60, and 90. We have a problem, though. Shh. They want me to do what with theta? Double it. So let's go ahead and double it. So this is still 0. This is 60. This is 90. This is 120. This is 180. So be careful when we go back to reference this. The purple is what we're going to use for the reference, okay? Not the red. Okay. So the only one we need to fix is this is going to be a 60 and this is going to be a 0. Oh, what do you guys notice? How many references are there in the pattern? There's only 3 references in the pattern. Okay, so what is the sign of 0? It is 0. So 5 times 0 is 0. We have another 0 down here. Let's just go ahead and fill it in. Cool? Okay. 60. What is the sign of 60? No sign. Square root of 3 over 2. Okay. Give me a second because I forgot what this equals. So it is approximately 4. It's 4.3. We're just going to go with 4 to make life easier, okay? Okay? All I did was 5 times the square root of 3 divided by 2. Don't freak out. For 0, okay, the sign of 0. Sign is y. On this line, on the 0 line, y is worth 0. Cool? All right. So all of my 60s are going to be 4. 90. 90. What is the sign of 90? And 5 times 1 is 5. Question. Okay, so I'm going to plot the points. 0, 0. Oh, what am I doing? Where's 0, 0? At the origin. Okay. So on the 30 degree, I'm going to go out to 4. On the 45 degree, I'm going to go to 5. On the 60, I'm going to go to 4. 60 and 4. And 90 back to 0. Looks like that. How would you describe that? Looks like a flower petal, okay? All right. Ready? 90 touches back at 0. All right, so we have 120, 135, 2, sorry, I messed that up. Shh. 150, 180. Now I need to double it. $240, $270, $300, $360. What type of angle is 240? It's a 60. What type is 270? A 90. 300, 60. And 360 is a 0. Right? 360 takes you back to 0. 360 minus 360 is 0. 360 minus 240 is, oh, sorry, 120. Oh, you guys did it off of 180. We're good. Okay. So, 60, what's the answer for a 60? 4. This is, a 90 is what? 5, a 4, and a 0. And quadrant 2, sign is positive. So do I need to flip any signs? No. I'm going to plot it. Bump, 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 bump. So, do I really need to make a table for the third or fourth quadrant? No. Can you follow the pattern now? Yeah, once you get a pattern, you don't need to make the table anymore. Okay, so on this pole here, how far out do I go? 4, 5, 4. There's a petal. Last petal. What's this? 4, 5, 4. Petal done. Little sloppy there. Cool? All right. Okay, so I made you do it the long way, and eventually you're going to learn some shortcuts. Here's the start of the shortcut. A rose curve will either look like R equals A cosine n theta, or R equals A sine n theta. N is positive. Okay? Those are the two forms of a rose curve. You also need to know that A is the length of my rose. So in the one we just did, A was worth 5, and the tip of the petal was at 5. Good? All right. Symmetry. N. N is a variable. Okay, if N is even versus if it's odd. For symmetry, if N is an even number, okay, N is right here. N is connected to theta. N is connected to theta. If N is even, it has x-axis symmetry. It has y-axis symmetry, and it has origin symmetry. It has all of that. If it's odd, cosine, if it's odd and cosine, then it's x-axis symmetry. Why would that be? Cosine is x. And if it's sine, it's going to be y-axis symmetry. Only if it's in the form of a rose curve. Okay, number of petals. Okay, we have n is odd or n is even. If n is odd, n is the number of petals. Okay? If n is even, then 2n is number of petals. For example, the last problem I just did, n was worth what? 2. So 2 times 2 is 4. Okay? So here is a sample problem I would like you to do. R equals 4 sine 3 theta. I want to know the length. I want to know the symmetry. And I would like the number of petals. Try that one now. Okay? What is the length? 4. Okay? What's the symmetry? Y-axis, Y. And, whoops, sorry, let me undo that. Okay, so the length is 4, the symmetry is y-axis because it's odd, okay, n is odd, n is 3, and it's sine, which means it's going to be y-axis. How many petals does it have? 3. Okay, another practice one down in this curve over here. Would you please try r equals 7 cosine 4 theta. I can't fit it there, sorry. So I want to know the length, the symmetry, and the number of petals. Okay, by now you should have the answer. So, what is the length? 7. Okay, what's the symmetry? All, because it's even. So it's all, and the number of petals is 8. How did you get 8? Double the 4, so 2 times 4 is 8. Okay? What? Because 4 is an even number. Okay, so if it's an even, you double it. If it's odd, you keep it. Okay? So from now on, if you see an equation that looks like this, you should be able to tell me the number of petals and that it's going to make a rose graph. Okay? With the rose curve. Now, tomorrow, we will go into the detail of Le Méchant. There are 4 different Le Méchant. You already graphed one. And we'll look at the patterns. For homework tonight, It is these two problems. What do I want to know? Length, symmetry, and number of petals. This is what your quiz will have on it.